Hey folks, this is Miss B back talking to you from my home. We've kind of gone remote here. It's been a while since we've been together. I have some new software, I have some new hardware, and this is the first time I'm really using this to make a recording to help you folks continue with your studies. So here's the big test here. So my first question is, can you read this? Hopefully you can. As I said, my handwriting's lousy on a good day, so I'll do the best that I can to make this as neat as possible. So when we stopped, the last thing we did was we were looking at quadratic equations, and now we're going to look at things that are similar to quadratic equations, but they are equations that are quadratic in form. So they kind of are like a quadratic equation. So let me just kind of go down to my next page here. And these are things that are quadratic in form. And what we're going to do is all of these are going to be solved with some kind of substitution, or sometimes it's referred to as a change in variable. All right, so let's see, for instance, and I'll be honest with you, oops, looks like I went a little too far. I'll be honest with you, these are all a little bit on the rigged or contrived side. So let's say, for instance, if we were going to look at this first one here, and I'll be honest with you again, it is, when you're looking at this, it is the term that is in the middle. So we're going to change variables, and please make sure you change variables. So that, what if I was to say that p squared is equal to t? If we were to square both sides, that means that p to the fourth would be t squared. Okay, so let me kind of go back to my other color here. So if I make those replacements here, I'm going to have t squared plus t minus 12 is equal to 0. And that looks like something that could be factored. So we know for factoring factors of 12 that actually differ by 1, that's going to be a 4 and 3 combination. So let's say it looks like to me this is going to be a t plus 4, t minus 3. So that means that either t is equal to 3 or that t is equal to a negative 4. Now the thing is anytime you do a substitution or change a variable, you want to go back to the original variable. So I initially said that t was equal to p squared. So that means that I could say that p squared is equal to negative 4, or that p squared is equal to 3. Now, I want to know what p is, not what p squared is. So let's say, for instance, and this is so much fun, I get to play with all these colors. What if I was to take the square root of both sides? So that I would end up with p is equal to plus or minus the square root of negative 4, or that p is equal to plus or minus the square root of 3. Now, as it says in the instruction, we want to write our answers in solution set. So, and let me just do one more simplification here. That means that p is going to be plus or minus 2i, because we know if we are taking the square root of something negative, we end up with a complex number. So in solution set, I am going to have 2i, negative 2i, the square root of 3, and a negative square root of 3. All right, so we're not used to having equations that have 4 solutions, so this is a little bit new for us. But here we ended up with 4 solutions. Sorry if I just misspoke a moment ago, but an equation with 4 solutions. But notice my exponent here. It's a 4. That's no surprise there. All right, so let's try something else here. So this one here, again, I'll be honest with you, these are always a little bit on the rigged side. It's the guy in the middle. So what if I was to let, I'm going to stick with capital T here, is equal to x minus 4. So that t squared is going to be x minus 4 squared. I mean, this is a Surface Pro that I'm working with. This is all a little bit new to me. All right, so let's make these replacements. So that I am going to have t squared minus 6 times t minus 55 is equal to 0. Now, if we're trying to factor this, we're trying to say, okay, well, what factors of 55 happen to differ by 6? And I do believe this is going to be a 5 and 11 combination. So if I had something like t here, a t here, we have a 5, we have an 11. Now remember, if this sign here is negative, that means the signs in my parentheses are going to be different. And the larger one will have the negative sign, so it's going to be a minus 11 and the plus 5. Okay, sorry if I'm sniffling here. So I get solutions of t is equal to 11, or that t is equal to negative 5. Now, as I said before, anytime you're doing a problem like this, you want to go back to the original variable. So we're going to go back to this one here. So I could say that x minus 4 is equal to negative 5, or that x minus 4 is equal to 11. So if I add 4 to both sides, in this case here, I get x is equal to a negative 1. Over here, if I add 4 to both sides, I end up with x is equal to 15. Now you're saying, well, why is this different than the other one? Well, let's just think about this. If you were to multiply this all out, put your like terms together, your largest exponent is going to be a 2. Over here, my largest exponent was a 4. Maybe that's why we ended up with more solutions in problem 1 than we do in problem 2. But again, if we write our answers in solution set notation, we get a negative 1, comma, and a 15. So these are almost like quadratic equations, but not exactly. All right, so let's kind of scooch down here. Now, if we're looking at this problem number 3, this looks a whole lot like some of the ones that we did in chapter 9 where we had radical equations. So one thing you could do is, yes, you could get this square root by itself. I think that might be a lot of work here. So first of all, I'm going to get everything on one side so it looks more like a quadratic equation. Right. Now, let's do a substitution. I love playing with these colored pens. What if I said the square root of a is, again, I'm going to go with capital T again, it's my favorite letter today. Now, what we end up doing is squaring both sides so that a is equal to t squared. Now, I'm going to have t squared minus 9 times t minus 36 is equal to 0. Again, this looks factorable to me. We want factors of 36 that are going to differ by 9. So I'm thinking this is a 12 and 3 combination. Again, negative sign here tells us that the larger number is the one that's negative. So that I end up with solutions of either t is equal to negative 3 or that t is equal to 12. Okay, as I've said before, let's go back to the original variable. All right, so up here where we did the substitution, so I'm going to say the square root of a is equal to 12, or that the square root of a is equal to negative 3. Let's get a little bit more room here. All right, so that means that a, if I was to square both sides, is 144, and here if I square both sides, I'm going to get 9. Now, just like the problems that were in chapter 9, where we're dealing with something with those square roots, I really think we should check our answers. So let's kind of go back to blue. So let's go, we're going to check. There's my little abbreviation for check. All right, and again, you want to go back to the original problem. So I am going to say 144 minus 9 times 144 is equal to 36. Okay, so if that is the case there, obviously you're going to take the square root of that 144 and end up with 12. All right, so I'm going to have 144 minus 108, sorry about the gap there, is equal to 36, and in fact it is. So that answer works. Now, let's try the other one. So if I had, say, 9 minus 9 times the square root of 9, which is 3, sorry about the mess there, we get 9 minus 27 equals 36, which it's not. This is a negative 18 is equal to 36. So this answer needs to be tossed out. Our only solution is the 144. Okay, all right, now this one over here, again, we're going to do some kind of substitution. So let's try a new color here. Now, again, it's the one that's in the middle. I'm going to say that x to the negative 1 power, again, I'm liking capital T today. If I take x to the negative 1 power and square it, I end up with x to the negative 2, which is going to be our t squared. So I am going to have 4t squared plus 4 times t minus 15 is equal to 0. All right, so now if we are going to factor this one here, okay, so let me see here. I'm going to roll up and get a piece of scrap paper for just a moment here. If I could do that. And actually, I'm going to put a piece of scrap paper right in here now so that I have something to kind of scribble on. Let's cancel it. As I said, new software. What can I tell you? It's all interesting. We're all learning here. Insert a page. And I want a blank page here. All right, so I was trying to factor something like 4x squared, or excuse me, t squared. Now let's see, can I use the eraser here? I sure can. Look at that. It's like magic. All right, so let's go back to writing again. So I had 4t squared plus 4t minus 15 is equal to 0. So if we're going to factor this, let's see here. Let's say if I try the 2 and 2 combination, things that go into 15, of course, are things like 3, 5, 1, and 15. I don't have to go both directions because these things are the same on top. So if I multiply this way, I get 10. If I multiply this way, I get 6. And if we look at these two numbers here, yes, they in fact differ by 4, which is what I wanted. So the way that this is going to factor, we're going to have a 2t and a 2t. Sorry about the scrapbook here, but I needed it. A 5, we need a 3. So let's see, the larger number will get the plus sign. So larger side number, so plus is on the right, minus on the left. Okay, so let me go back to where I was. There's my little piece of scrap paper. Let me find my page here. Okay, we're getting warm. All right, so let's see. We have this factored here. 2t, 2t, that was a plus 5 and a minus 3. All right, so if we were to take each factor and set this equal to 0, I would get something like 2t is equal to negative 5, or that t is equal to a negative 5 halves. Likewise over here, I could say 2t minus 3 is equal to 0, 2 times t is equal to 3, or that t is equal to 3 halves. Okay, now let's go back to our original variable. This process is known as the back substitution step. Okay, so I could say that x to the negative 1 power is equal to 3 halves. Now, let's remember our rules of exponents. X to the negative 1 power is the same as 1 over x, so that means 1 over x is 3 halves. If we wanted to do a little cross multiplication, I would have 3x is equal to 2, or that x is equal to 2/3. Likewise, over here, if I said t is equal to negative 5 halves, that means x to the negative 1 is equal to negative 5 halves, or that 1 over x is negative 5 halves. Okay, let me just get my eraser there. Things got a little bit crazy. There's my negative sign. All right, so again, I can cross multiply. So I have negative 5x is equal to 2, or that x is equal to a negative 2/5. Okay, so again, if I was to write this in solution set notation, I'm going to have 2/3 and a negative 2/5. Alrighty, now let's kind of scroll down here and try a few more. So I'm on the second page here. Now, in this case, I have z to the 2/3 power plus z to the 1/3 power minus 6 is equal to 0. So again, we're going to do a substitution, and as I said, these are all kind of contrived, if you will. It's the term in the middle. We don't include the coefficient, just the variable part of the term that's in the middle. So again, what if I was to let capital T be z to the 1/3 power? So now if I was to square both sides, I end up with z to the 2/3 power. Okay, so let's substitute this in. This is going to be, looks like t squared plus t minus 6 is equal to 0. This is also factorable. So I would have a t plus 3 and a t minus 2. Okay, so that means either t is equal to 2 or that t is equal to negative 3. All right, so let's do it again. We're going to go back to the original variable. I'm really liking this orange color. It's kind of fun. So that means that z to the 1/3 power is equal to negative 3. Now, again, we have to remember something from chapter 9, and that is if I am taking something and raising it to the 1/3 power, that's equivalent to saying I'm taking the cube root of that expression. So in order to undo a cube root, we need to cube both sides. So that I would have z is equal to negative 3 to the 3rd power is going to be negative 27. Likewise, if z to the 1/3 power is equal to 2, that means we're taking the cube root of z is 2. I'm going to cube both sides, so that means that z is going to be 8. And again, if we want to check our answers here, and we can take these and put them into our calculator. Now, the only thing you have to be careful of is if you're going to check this on your calculator, if you put these expressions in, especially that negative 27, we want to put that 27 in parentheses. We want to put this exponent, that 2/3, in parentheses. Otherwise, it may interpret it incorrectly. Okay, now we got, I think, 2 more using the same function here. So here we want to determine the values of x that solve the equation f of x is equal to negative 35. So here we're trying to find x values. I'm going to set the entire function equal to negative 35. So I'm going to say x to the 4th power minus 6x squared minus 27 equals negative 35. Now, before we start, doing any substitutions here, let's get everything on one side so it looks more like a quadratic equation. So I would have x to the 4th minus 6x squared. If I add 35 to both sides, it looks like I end up with 8. Now, again, what if I let, let's say, x squared equal capital T, so that x to the 4th power is equivalent to t squared. So I have t squared minus 6t plus 8 is 0. This looks pretty easy to factor here. So I would have t minus 2, t minus 4. All right, so let's solve for t here. And as I said, we're going to go back to the original variable. So this guy here, we're going to replace it with x squared. So I'm going to say x squared is equal to 2, or that x squared is equal to 4. Now, I want to know what x is. So let's take the square root of both sides, so that I am going to get x is equal to the positive or negative square root of 2. Or over here, if I take the square root of 4, I get the positive and negative square root of 4, which of course is 2. So now if I go and write my answers in that solution set notation, I have the square root of 2, I have a negative square root of 2, positive 2, negative 2. Again, look at this exponent. It's a 4. I got 4 answers. This is not an accident. All right, now same function, but now it says determine the zeros of the function. So what we have to remember is that the zeros of a function are the x values that make the function equal to 0. Okay, now let me fix that handwriting there. Oops. Okay, so what we're going to do is we are going to set the function equal to 0. So I would have x to the 4th minus 6x squared minus 27. This is all equal to 0. Now, just because it's there and I can do it, I am going to use the same substitution down here. All right, so that means I'm going to say 0 is equal to t squared minus 6t minus 27. Again, this looks factorable to me, so I get something like a t minus 9 and a t plus 3. All right, almost done. So take each factor, set it to 0, solve for t. I get two solutions for t of either t is 9 or t is equal to negative 3. Okay, so let's go back to our original variable. So I would say x squared is 9, or that x squared is equal to negative 3. So if I was to take the square root of both sides, I would get x is equal to positive or negative 3. If I take the square root here, I get x is equal to plus or minus the square root of 3i, or if you prefer to have the I in front of the square root, that's fine with me as well. So if I write my answers in solution set notation, I'm going to have something like 3, negative 3, I times the square root of 3, and negative I square root of 3. All right, now let me write a couple more problems here, and you folks try these on your own. So let's say, for instance, if we had something that looked like this. Okay, if we had something like, oh, I don't know, x minus 6 squared minus 8 times x minus 6 minus 20 is equal to 0. Why don't you give that a try? And secondly, let's see if let me think of another one. Let's say if you had something like y to the 2/3 plus 5 times y. Wait one moment here. I don't know what happened there. I made a mess is what happened there. Let me fix that. Okay, as I said, you get to learn to work all these new toys here. It takes a moment. So how about 5y to the 1/3 plus 4 is equal to 0. So try those two problems and see what happens. Thank you so much, and I miss you all terribly.